It is very, very windy here today. A couple of branches from trees in front of my house even came down. Do you remember what that would be from? Why we would have strong winds? It's because of a steep pressure gradient. Good. Excellent. So when plate tectonics was articulated in the late 1960s, they left this kind of open-ended because they knew that they did not know everything. But they had enough to articulate the concept of plate tectonics with the full realization that over time, Earth scientists would fill in the gaps, as they continue to do. There was a satellite that was put up into space about 4 or 5 years ago, and the whole idea was to find out if there are any microplates that were missing. There you go. So there were some anomalies in the theory, and over time, at least some of these anomalies have been figured out. Remember, overwhelmingly, tectonic activity happens along the plate boundaries. But along the west coast of North America, and then in the Hawaiian Islands and Yellowstone, as in where Yellowstone National Park is at in northwestern Wyoming, the southern part of Montana, there were things that people understood were there, but they didn't understand why they were there. We're going to go through that right now. First of all, there's something called terranes. Notice this word is derived from Latin, terra, which means land, same as Spanish tierra or Italian terra. So these are parts of a continent that are not geologically connected or geologically part of the continent. They're made of different rocks than the rest of the continent is made of, and they were connected through plate movement, which I'll explain in a minute. The other thing is what's known as hot spots, or are known as hot spots. I'll explain those more in a moment. We're going to start with the West Coast part, since we're on the West Coast anyway. So if you look at this map over to the right-hand side, I know I should be starting from the left, but I'm starting from the right, whatever. Notice along the western part of the United States, it's very rugged, very mountainous. We now know that mountainous areas are the result of tectonic activity. If you look at the center part of the continent, it's very flat, not tectonically active. This shows you the current west coast of North America. However, remember, North America and South America, for that matter, have been shoved to the west by the Mid-Atlantic Ridge, which is a site of crustal divergence. And they've moved some 1,500 miles away from the Mid-Atlantic Ridge. It's not as if, as those continents were being pushed to the west, there was nothing there. Because, of course, there's seafloor and islands, mountains, all of these things. And it would be a little bit like this. If you had a bulldozer and you put that scooper thing down in the front, which I believe is called the bucket, and you put it down to the dirt, and then you drove the bulldozer forward, dirt is going to be stuck onto the front and pile up, accreting onto the front of the bucket. A similar thing has happened to North America. Whereas North America has been pushed to the west, it has accreted material from the ocean onto the sides of the continent. This is the stuff that we call terranes. If you look at now the map on the left side, or the three maps on the left side, you can see during the early Triassic, and then during the Jurassic, and then the Cretaceous, what's happened, which is as North America was pushed towards the west, it began to absorb mountains, seafloor, islands, and it began to accrete that material onto the side of the continent. And in fact, in some places, more than 100 miles inland, the material that makes up the western coast of North America is actually material that's been accreted out of the ocean because of plate movement. Earthquakes and volcanic activity are closely linked to plate activity. Almost all earthquakes and volcanism happen along the plate boundaries. Take a look at this map of earthquake epicenters. Each one of those dots represents earthquake epicenters on the planet. Notice how similar it looks to the shapes of the plates. This is volcanic activity. A little bit less so, but you can still tell. Those are the plates. Take a look. Quick look back. Quick look forward. Yeah. Most of the activity happens along the plate boundaries. A glaring example of an anomaly is the Hawaiian Hot Spot. A hot spot is a place inside the mantle where for some reason the mantle makes extremely hot magma, liquid rock, hotter than everything around it. And of course, hot things rise on this planet. That magma then rises to the surface, breaks through the crust, and then flows out onto the crust. There's several clues that indicate that Hawaii sits over the top of a hot spot. First of all, notice the island chain. It trends northwest-southeast, with Kauai, you can see there, in the northwest, and the big island of Hawaii in the southeast. Notice also, the youngest islands are the ones in the southeast, and the island chain, as you go up the chain towards Kauai, the islands get older and older and older. The oldest islands are generally the smaller islands. And the big island is the only island that has an active volcano on it, which sits kind of in the southeast of the island itself. This is where Kilauea is at, the most active volcano on the planet. If you look at the way the Pacific Plate moves, you can see the arrows indicating the way the Pacific Plate moves. The Pacific Plate moves from the southeast towards the northwest, exactly lining up with what the Hawaiian island chain looks like. And in fact, the Hawaiian island chain is sitting over the top of a hotspot, and the Pacific Plate rolls over the top of that hotspot almost like a conveyor belt. So that if you were sitting under a conveyor belt and you had a knife and you were popping holes in the conveyor belt, as it moved along, you'd pop one hole and then that hole in the conveyor belt would move away. Then you'd pop another one, that would move away. This is similar to what's happening with the Pacific Plate. It rides over the top of that stationary hotspot that's in the mantle. The lava flows out, creating the islands, and then they're carried away. And as you go up the chain away from the big island, the islands not only get older, they get eaten away by the waves because there's no more lava coming out of them, because the volcanoes are all deceased on all of the islands except for the big island of Hawaii. So the plates move over this hotspot like a conveyor belt. You can see I've circled where the Hawaiian island chain would be in the Pacific Ocean, and you can see the trend of it, which mirrors the movement of the Pacific Plate. That's because it sits over the top of that hotspot. Yellowstone is in all likelihood the same thing, where Yellowstone National Park is the place on the planet with the largest number of geysers, and this is largely the result of the fact that that part of Wyoming is sitting over a hotspot that the continent has ridden over the top of.